This is a video on integration by parts. First, we're going to cover what integration by parts is. We're going to cover the Liat rule, and then we're going to cover 3 examples. So first, what is integration by parts? Integration by parts is a technique that we use when we want to integrate a function that can be made of 2 smaller functions multiplied together. For example, e to the x times sine x, x squared times sine x, 2x times e to the x. It is used in an indefinite case and a definite case. The way that we use it is we have a u function times a v prime function. The integral of that, we're trying to figure that out, is equal to the u function times the v function minus the integral of the u prime function times the v function. So the Liat rule is how we choose which function we're going to use as a u and which one we're going to use as v prime. Liat stands for logarithmic, inverse trig, algebraic, trig, exponential. Here are some examples of each of those. When we are using Liat, we decide which when we look at the 2 functions multiplied together, we choose the one closest to the L to be the u, the one closest to the e to be the v prime. So for example, in this question 5, e to the x times sine x, we have an exponential function and a trig function, t and e. Therefore, u would correspond to the t, which would be sine x, and the v prime would correspond to the e, which is e to the x. Because as you can see, v prime, e to the x, u, t. The one furthest to the left is u, furthest to the right is v prime. So for the first example, we have the integral of 2x times e to the x. So according to the Liat rule, u is going to equal x and v prime is going to equal e to the x. Because remember, v prime is going to correspond to the most rightmost function, and u is going to correspond to the leftmost function. In this case, u equals x, which is algebraic, and v prime equals e to the x, which is exponential. So now what we need to do next is figure out the derivative of u and the integral of v prime. We need to figure out what v is, what u is, what u prime is, and what v prime is. So this is a little bit of quick integration, figuring out what u prime is and what the integral of v prime is. And then we have all 4 here. Then we plug into the formula here, which is the integral of u v prime dx equals uv minus the integral of u prime v. So as we see right here, I took out the 2 to make it in front. 2 u v prime dx equals the 2's in front. So this is u times v minus u, which in this case, u prime, which in this case is a 1, times v, which in this case is e to the x. Then we just do another quick integration of e to the x, and we get this as our final answer. Remember the c. Next question. This is a definite integral. So again, we got to figure out what u prime is, what v prime is, what v is, and what u is. Now I selected u to be x squared because it's algebraic, furthest to the left on Liat. And then v prime is sine x because it's trig, it's to the right of the algebraic. So v prime is t, u is a, u is on the left, v prime is on the right. Then we figure out the integral of v prime and the derivative of u. And we plug into the formula again. So this would be u v prime equals u times v. Remember, according to the formula that we had earlier on, for the definite integral, we have our bounds, minus u prime times v. Then we follow through. We do a little bit more just putting in our bounds, and one more integration on this side. What you will find is that this function here cannot be integrated normally. Instead, you have to do integration by parts again. So in this case, we have u being x, v prime being cos x, algebraic, trig, algebraic, trig, and then u prime, we find that, and then we find v, not v prime v, and then we put it all together again, where this is u, v prime, u, v, u is 1, and v is sine x. And then we plug in our bounds once more, and we get our answer. And for the last example, it's a bit different. E to the x sine x. Now, the other ones had an algebraic term. In this case, it's x squared. In this case, it's just regular x. What that did is the algebraic terms eventually got whittled down. So this went from x squared to one term that had an x to one term that had nothing, and we could integrate that. Here, that's not going to happen. Let's go for it though. L-I-A, algebraic, we don't have that. T, we have trig, so u is going to be trig, and then e will be, e to the x will be v prime. We find the derivative of u, we find the integral of v. We plug it in. So we have u times v prime equals u times v minus v times u prime. So now we need to integrate by parts once more. So we integrate e to the x cos x, following the same procedure. U is cos x, v prime is e to the x, because liat, the e will reference the exponential term, and since that's further to the right than the trig term, because it's liat with the e on the end, u will be the trig term, and v prime will be the exponential term. Then we find again the derivative of u, the integral of v, and we continue on. So now we'll do integration by parts once more. The integral of, this will be v prime rather, times u equals v times u minus v times u prime, and we get this. Now what you will find is that if we put these two together, so we found this part, we plug this equals term into here, and we get this expression. The integral of e to the x sine x equals e to the x sine x minus all of this. Now what you'll notice is e to the x sine x is over here, e to the x sine x is over here. So continuing to expand it out, we get something like this. I will bring this e to the x sine x term to the left side. Therefore, we get 2 e to the x sine x equals all of this. I will divide by 2 on both sides, and then we get the answer that we were looking for. The integral of e to the x sine x, which was the original, equals e to the x sine x divided by 2 minus e to the x cos x divided by 2. Remember the plus c. And here are your 3 pages.